Hey folks, how's it going? Let me know if the audio is okay. Using a different setup right now since I'm in front of the machine and talking live. I've got a lav mic hooked up. Give me a affirmative in the chat if everything sounds okay, and just start complaining vehemently if I sound terrible. Okay, so let me pull up the agenda for today. Today we just want to answer a couple of questions from users, just rapid fire. What are some of your problems? What do you want to know about? And this is the fastest way to just shove information at you guys. So, I guess to start with, let me just cut to the whole machine view since this is far more interesting. Transition, cool. All right, so I guess the first thing we want to just sort of address is just generally how do you get started with a CNC? How big do you go? So for the most part, the defining criteria for how you pick a CNC is how big of a project do you want to machine. If you've got a sign that you want to make that's 2 feet wide, it's not going to fit on a stock size machine. So scaling up, depending on how wide or how deep you want to go, is a good way to get started. And in terms of learning CNC, figure out, I always say to start with one project, learn that, and that way you're not trying to learn everything about CNC. If you're trying to learn about like 3D machining and 2D stuff and CAD, CAM, and all that other stuff that goes into CNC, you're going to be overwhelmed. Start with a simple project and then just go from there. There is a little bit of noise in the background because our compressor hasn't shut off yet. We were just running some machines. Hopefully once the pressure levels out and our machinist stops making parts, we can quiet that down. I think if you have any specific questions about picking a CNC, drop them in the chat and I'll try and get to them. But I'm just going to rapid fire, just blaze through these questions, and at the end we'll have a little more time for Q&A. So how do you adjust spindle RPM, and does it matter in CAM? So if you have a VFD, or a variable frequency drive, those spindles can be connected through a pulse width modulated signal that comes from the Carbide Motion board. So on these boards, there is a PWM signal pin. I know it's going to be hard to see, but if you look at your own machine, you can see it. It's labeled PWM, at least on version 2.4 boards or later. So if you have a VFD drive that can pull the information from that PWM port, it'll adjust its speed automatically. Otherwise, most people have a router, and it's just a matter of adjusting that dial. Whatever your speeds and feeds, whatever your cutting recipe calls for, adjust the dial to the appropriate speed, and that's basically how you change speeds. If you have, so if I change out one tool for another and I've got a different RPM that's needed for that new tool, you've got to make sure you adjust your dial between each tool change. Does it matter in CAM? Not really, because the only thing that the CAM will directly influence is the feed rate of the machine. So it's kind of independent of RPM, even though RPM is sent there. And again, if you're using a VFD, that will be controlled automatically through the board. It does matter, but if you're on a router, the RPM that's in your CAM setup really doesn't matter. But what it does change if you're using something like Fusion 360 is Fusion will tell you what your chip load is. So if you remember back a couple live streams ago, I was talking about how much material does a cutter slice into every time it spins. That's going to change depending on your RPM. So if you plug in the wrong RPM into your CAM software, that value won't be calculated correctly, and you're not going to have as good an idea of what are the physics of the cut that's happening at the end mill. Do the stepper motors need maintenance? Not really, no. They're self-contained units. As long as you basically just keep them clean, especially making sure no dust collects on or under the pulleys, they're basically good to go indefinitely. They might get a little warm to the touch, but as long as they're not like scorching hot, and using your hand is not a good test of whether or not something is hot. Metal conducts heat really well, so even if something's like 120 Fahrenheit, if you touch a piece of wood that's that temperature, it'll feel warm. If you touch a piece of metal, it'll feel scorching hot because that heat is going into your hand really fast. So like by feel is not a good way to tell whether or not something is too hot. If you're really curious, use like an infrared thermometer. Shiny reflective surfaces, you might see that every now and then I've got a piece of masking tape over it. That's just so on my infrared thermometer can get a good read on it. But for the most part, these things are good to just run continuously, just for hours at a time, and you shouldn't need to do anything other than keep them clean. If you're not using dust collection, stuff can build up there. It'll just sort of wear stuff down and get in the way or get clogged. It'll clog the V-wheels, it'll clog the belts, but hygiene is really the only thing that matters for stepper motors. What CAD software do I use and where does G-code come from? So when, I guess there are a variety of ways you can create a model and then create G-code. So those are the two big steps in your workflow. How do you come up with a 2D model, and then how do you come up with the toolpaths that your CNC will run? So I'll switch back to the my screen. Let's see, primary display, and cool. So let me open up Carbide Create. So Carbide Create is one such way where you can make 2D toolpaths and create 2D designs. Running a CNC is basically coming up with a model or a shape you want to cut, and then creating the instructions for the CNC to follow that shape. So I use a combination of Carbide Create or Fusion 360 for my design stuff. These shapes, these 2D vectors, can also be generated in a vector graphics program like Illustrator or Inkscape. So you can import these, you can generate them yourself here, you can draw splines, whatever. But it's once you have a shape, you can go into the toolpathing workspace here, or it's the manufacturing workspace in Fusion, or if you're using Vectric, it's something else. And then it's basically pick a shape and pick how your machine should move around that shape. So here I can cut on the line, I can cut inside the line or outside the line. If you really want to sort of, if you're coming at this from a beginner perspective, we have some more comprehensive tutorials that we can link to. Just reach out to us, support@carbide3d.com, and we will link you to all the relevant information. Let's check the next question. How does the Shapeoko do with precise, detailed work? I wish I brought an example, but for the most part, the machine is extremely accurate. It's not as rigid as the Nomad, so when you push on it, it'll shift by a couple thou. So if you're trying to do really detailed, super precise work in tough materials, if you're trying to cut, like, say, a branding iron, the Nomad will hold those tolerances a little better. You'll get a little less chatter. But if you're doing something like PCB milling, the end mill is just barely grazing the material. And if there's not a lot of resistance on the machine, it can actually travel extremely accurately, like almost as accurately as the Nomad. The theoretical resolution of this is 1/40th of a millimeter. So realistically, you're never going to cut something that small, but that it'll get you within like 2 or 3 thousandths of an inch. So that is the precision and repeatability of the Shapeoko. Whether or not you achieve that depends on how strenuous or aggressive your cuts are. And that's why a lot of the times I'll say you should take a finishing pass or a spring pass. Basically, just once you machine something, just go around that edge one last time and let the cutter just shave off the last bits of material that might have been left behind. How much newton meters does a servo stepper motor need? Hard to say. I can't give specific values here. Dust covers for V-wheels. I don't believe there are any plans for it soon, but I know there are some 3D printed designs out there, and third-party offerings for that. Let's see, I don't have an exact date on the HTZ, but we're working on it as fast as we can. Is it possible to add a fourth axis in order to engrave or mark round objects? You really don't need a fifth axis to do that. A lot of people do that with a rotary fourth, which we do not have at this moment because you need an extra stepper driver. So our control board is literally, it's physically incapable of controlling another axis. There are people who've hacked their own, but that is an unsupported thing, so you're kind of on your own in that case. Speaking of motors needing maintenance, how do you tell the brushes need replacing on the spindle? If you start hearing this not cutting right, or like the RPMs drop, or you lose power, or just it stops turning on, you can check the brushes. I don't know if I have a screwdriver here, but basically, actually, nope, that's, I don't, nope. You can unscrew these and pull out the brushes and replace them. Our routers come with an extra set of brushes, so you should be able to just pop in new brushes and keep going. Any guidance on how to create a wasteboard flattening toolpath? Basically, get the biggest cutter you can find. If it's 1/4 inch, great. If you get a router style flat end mill, you can like a 1/2 inch or a 3/4 inch, just a straight flute bit. You can use that, or there are wasteboard surfacing bits. Basically, just make a square or rectangle as big as the area you want to machine, and then just pocket inside that just a small amount, maybe 0.01 inches, maybe. Let's see, can you pause a job overnight? You can if you have to. It's not ideal just to keep the entire machine powered on if you don't have to, but there theoretically shouldn't be anything wrong with that. If you can also split up your toolpath, you can also just run 1/2 of it and then come back the next day. If you power off the machine and turn it back on, Carbide Motion will remember where the last 0 point was. So let me switch back to different view and open up Carbide Motion. So right now the machine is turned on. If I tell it to go to the last place where I zeroed it, it'll go right here and know where that is. If I power off the machine and then power it back on and rehome everything, and I tell it to go back to the previous X or Y offset, it'll go back right here. So you can turn off the machine and just run the second half of your toolpath without worrying about the 0 being lost. All right, back to the machine because my computer screen is boring. I'll get back to any other questions in the chat after I go through a couple more of these questions. How do you tile a 24-inch circle on the XXL? You really wouldn't have to. The double XL is big enough. This question actually, it might have been the XL. Let me change that. You would have to come up with a toolpath that basically cut a semicircle, and then find a way to index your part. So let's say this is a shape I want to cut, and pretend it's really big, really long. You'd have to generate a toolpath that only touched 1/2 of your part, and then either mirror it, reverse it, and then shift the part down so that this area was in the machinable region, and then locate where that was. There's a number of ways you can do that. You could drill indexing pins in your stock, or if you have a perfectly cut square, like 24 by 24 inches, like let's say you did that on your table saw, you could set the part down and use a touch probe, figure out where it is, and then when you're ready, you flip around the part and you machine the opposite half. It's really just a little bookkeeping, making sure you remember where one toolpath is on a piece of stock relative to the other half, and then being able to find your new starting point. You can take some of the tips from our live stream on, two-sided machining. Some of those tips are still applicable for tiling workpieces, but if you want to make tiled toolpaths, you'll need, I think the only one I know of off the top of my head that supports that would be a Vectrix software. You can also sort of hack it in Fusion 360, but it's a little trickier. what end mills are best for what toolpath? All right, let's pull out some end mills. And then let me adjust the camera. Please hold, I need to refocus everything. And let's turn it this way. Let me check the chat just to make sure nothing's broken while I wasn't looking. Cool. So, here I've got almost every tool in the Carbide 3D inventory. Which one you pick depends largely on what you're trying to machine, how small your features are, and maybe the type of toolpath. So if I want to machine a small pocket with big, generous corners, you really don't need a small end mill. The larger a tool you use, the beefier it is, the less you worry about breaking it, the larger the flutes are, so you can take a big, aggressive cut, get those big, fluffy plastic chips that won't clog a larger cutter like this. But if you have really small corners or tight features, then you'll need a smaller end mill. So I just put that away wrong. The type of feature you're cutting will determine how small a tool you can use. Another constraint is typically if you want to cut around this part, a 1/4-inch end mill doesn't have the cutting length needed to cut all the way through the material. So you've got to go with the smallest tool that's still long enough to go all the way through your material. The non-cutting shank, a little bit of it can actually rub the material without doing too much damage, but if it's cutting against wood or MDF, it'll cause a little bit of charring potentially if it lingers a little too long. So it's always best to keep your cutting flutes at least as long as your material is thick. So basically size is the biggest constraint. Specifically for contour cutting in aluminum, I really like, single flutes. So these cutters have a single really large channel. So when it slices into aluminum, that chip has plenty of room to just get flung out of the cutter. So these are really good for just deep slotting around aluminum because they don't jam up, and it keeps the chip load reasonably high while reducing the stress you put back into the machine. So that would be one case where I would really prefer a single flute. But other than that, size of the end mill, size of the feature you're cutting is really how I determine what I want to use for cutting. All right, that looks like it's in focus. Next question. What do depth per pass and plunge rate mean? All right. So let's go back to the old desktop. Actually, you don't need to see any of that. So when you're generating a toolpath, there are a couple things you might see when you're changing the parameters. One of them is depth per pass, and one of them is plunge rate. Depth per pass is basically if you're taking multiple step downs. Here, let's bring the camera back up. So I need an end mill. So if you're cutting around, am I in focus? Let's get just a little bit closer. There. All right. So if I'm trying to cut out this piece, I don't want to just shove my end mill all the way to the bottom of the stock and rip through it. That'll be super stressful. It's going to sound terrible. It's probably going to break something. What you want to do is go around in multiple step downs. So you might go 1/16 of an inch at a time and just work your way all the way down the material, taking a pass each step down. So that is what your depth per pass is. How deep do you plunge for each pass that you make? Your plunge rate is how fast does your end mill enter the material. So for a material like wood or plastic, it can be a little higher because you can just, as this is spinning, it'll just drill its way into the material and then start moving sideways. for something like aluminum or even some harder plastics, you really don't want to just shove the end mill straight into the material, because it's going to cause a little bit of sort of kickback, and potentially like dip the RPM on the spindle if it doesn't have enough momentum. So controlling your plunge rate controls sort of just the shock loading of the end mill entering the material, but a faster plunge rate does also speed things up. So if you're doing a lot of like little cuts, it's your end mill's coming down, going up, moving over, coming down again. There's a lot of time in transition or translation. So if you minimize your retract height, how far up the end mill comes off the material before it moves, as long as it's above the height of any clamps or anything that's potentially protruding over the material, you should be safe to just maybe retract like a 1/16 of an inch, wrap it over, and plunge a shorter distance into your material. So plunge rate is really just how slowly, how controlled is that descent into your material. Choose one that's safe for your material, safe for your CNC, whatever it can handle, but that's what those two variables are. Okay, let's go wide again. And let's see what else is on the agenda. Let me check the chat real quick. Okay. If you don't have a bit sitter, but you do have a probe, what cases can't you use the probe? So for the touch probe, the bit 0, as we're calling it, the only time where this really doesn't work is if you have something really small that you're trying to machine, maybe like a small circular feature that this doesn't sit on, or if you're machining like a big topographic carving where this can't rest on top of your material. So let's pretend these outer walls weren't here, or maybe they are. Like the probe won't sit flat on certain geometry. So you'll know pretty quick if you can't set this down stably and pick up the 0 off of it. The other thing that might happen is maybe it's too tall, and if you use a touch probe, you're going to get a collision with the gantry or something. But it's a fairly limited case where this doesn't work. Also, if you're trying to only find the Z height, you don't need to put it on top of the material. If you define your origin point to be at the wasteboard, you can just pick up that height as well, and then maybe pick up X and Y manually. Let's see. Wheel lead screw, upgrade handle the weight of a 1.5 kilowatt spindle. It's pushing it. So I think someone did a test. The Z Plus will put out, I think it's like 40-ish pounds of thrust loading. You've got to subtract the weight of the carriage itself, the weight of the spindle, and the potential load factor of the end mill as it's being pulled through the material. I would say that's pushing it. The HDZ is really your best bet if you're going to put anything heavier than a router on your Z-axis. Okay, let's carry on. Can you cut acrylic and wood? Absolutely. I don't have any here, and I'm tethered to my laptop by my lav mic, so I can't pull it up, but yes, you totally can. And we have speeds and feeds. Let's go to the desktop. Built into Carbide Create, just to give you a ballpark starting point. So if you pick your machine and you pick your material, you can pick acrylic, you can pick hardwood, softwood, MDF, and each tool in this library will give you a reasonably safe starting value. As you get more comfortable with the machine, or you want to do more advanced things, you can totally speed this up. But this is just, since you asked, like if you don't know where to start, this is a safe place to start. Okay, let's see if there's anything else. What else is on the agenda? Z-carriage rollers getting loose, how to stop. Okay, so let me tweak the camera a little bit. And nope, that's down, I want to go back. So I've seen this happen where someone has V-wheels and the bolt in the back backs out, and all of a sudden they see an eccentric nut on the wasteboard and they're like, oh my goodness, like where did this come from? For the most part, this is, you just need a little bit of Loctite. So if you take a drop of thread locker, Loctite, whatever, put a drop in the nut and then you screw into it, that'll prevent it from backing out. And just remember that I'll have a wrench here, but as you're tightening the eccentric nut, rotate it clockwise, because otherwise if you turn it the opposite way, you might actually be backing out the bolt as you turn it. So tighten the eccentric nuts clockwise, and then use thread locker. That should keep that from happening. You can't see this right now, but my coworkers are heckling me from just off camera.
Encouraging you. Supporting you.
They are totally supporting me. So let's see. What are my thoughts on clamps? Let me pull out some clamps, and we can talk about them, and their pros and their cons. So let me make sure I'm still showing something that's on the screen. Down, let's pan over a little bit, let's zoom out a little bit, and that's close enough to in focus. So regular clamps, like our gator tooth clamps, these are great for just, you need to hold something down, they go on top of material. These are top clamps, and they're super strong because as they force down the material, they start adding friction, and that friction holds this piece in place. Super convenient to use. You can use them on literally anything. The only problem is these clamps go on top of the material. So if you're trying to machine a sign where you got to touch every square inch, including the corners, these are going to be in the way. And so that's why you might want to use something like side clamps. So different clamping for different purposes. This is also useful for, say, if you're trying to plane down a piece of wood, or if it's a little warped or cupped, you just clamp it down on the side, don't let it move up and down, and then just skim the top flat. So just two different styles of clamps. You can also use the cam style clamps, like the round ones that are eccentric. You bolt them down and they spin and they press in on the material. But depending on whether or not you need access to the top, that's going to determine what kind of clamping you use. Okay. Bumps felt while moving a carriage. Okay, so this is more of a troubleshooting thing, but let me pan up. Let me actually turn off the machine. So if you take your gantry and you just move it left and right, this should move, like you shouldn't have to like really force it. If you have to force it, you probably tightened your wheels too much, and they're applying too much, there's basically just too much rolling resistance. So you should be able to move this easily, like with a finger or two. If you push it too fast, it's going to start to judder a little bit, and that's because the stepper motor in the back is acting like a generator, and it's briefly activating the motor itself. So as you push it, you generate electricity, builds up a current, and it basically just locks up the motor. So if you push it slowly, it should be relatively smooth. If you're pushing it and you're feeling like a little bit of extra resistance, like in a particular spot, like there's a flat spot on the wheel maybe, and you push it and it rolls smoothly, and then it locks up again a little bit. You probably either have a flat on your V-wheel, like maybe when you were first setting up, you tighten the eccentric too much and you deformed the plastic of the V-wheel. Do I have a V-wheel here? Yes, I do. So the V-rail probably just pressed down on one spot for too long and flattened it out, or you have a crack that developed in the V-wheel somewhere. No one likes machine grease. That you potentially have a crack here so that this V area is flared out a little bit, and that would cause the V-wheel to sink down a little bit when it rolls onto that cracked area. So just check all your V-wheels in the area where on the axis where you're having the sticking issue. it's most likely a mechanical issue. The rails themselves are probably fine. The belts are probably fine. First thing to look at is the V-wheels. Okay, let's zoom out again. Let's see what's on the agenda. How do you program a machine? That's through a CAM software. No, we don't have a conversational programming option, though that would be awesome. Are there any work holding methods I would avoid? It really comes down to what you're machining and how you need to machine it. So again, the whole discussion of top clamps versus side clamps, or if you want to get fancy, you could also take like a sheet of plywood and screw it into your MDF. Basically, whatever doesn't get in your way. As long as you can machine it out without making your life miserable by trying to dodge clamps or like fighting, like if you have a super flat piece of material, like plastic, fairly dimensionally stable, double-sided tape also works great. It's whatever works. Avoid anything that's going to give you issues. Like if clamps are going to get in the way, don't use top clamps. If you have really warped pieces of wood, don't use double-sided tape. All right. Bit setter workflow. Let me double check the chat one more time. Okay, nothing too crazy. Any plans for Wi-Fi or Bluetooth add-ons? At this time, not really. The machine itself has a controller, but that has to be tethered to a laptop or some other G-code sending server. So I think some people have hacked a Raspberry Pi to work with it. But this controller can't operate standalone. Epoxy resin, basically just treat it like a hardwood. Other than that, like the same tools you would use, your regular upcuts, downcuts, those will work just fine in epoxy. Okay, bit setter workflow. I'm going to show you guys how the bit setter works. Let me just clear my table first, because that will cause problems. And get that out of the way. Don't need these. And that can stay. So I turned off my machine, so you're going to see the full cycle from start to finish. Step one, power on the machine. Let me switch to a view so you can see my laptop. Okay, so when you first load up the machine, connect to your cutter, and then initialize the machine. Up to this point, initialize. All right. Up to this point, everything is the same, regardless of whether or not you have a bit setter. Once this is finished homing, if you do have a bit setter, it'll move to the front and prompt you to touch off on that end mill. And that's so it knows that when you later jog around, wherever your zero height was set, be it at the wasteboard, at the top of a part, it takes this tool into account that's loaded at this very instant. So it says, please insert a tool. I've got one in there. Resume. It'll touch off, figure out the length of that tool, and then once it has that information, it'll be able to return to wherever I zeroed it before, which in that case, I did this beforehand. It's about here, and it should be, this tool should end up just barely grazing the top of this block. So let's jog over there. Let us rapid position to current X and Y. Current Z +6, so this will stop 6 millimeters above the plastic. Check, so looks good. If I were to change, if I were to just loosen that tool, move it up or down, and reprobe it, it would be able to come back to this same spot. If you weren't doing this with a bit setter, you'd have to use a touch probe or just eyeball it and re-zero your Z every time you change a tool. So I can show you how to run a quick program and what the tool change procedure looks like with the bit setter. Let me do that real quick. Sure, skip that. So I made a file that basically cuts two squares with two different tools. So what it'll do is once you load up the program, you start it. When you first start, it'll prompt you to load the tool that you need, which for this purpose, I'm just going to leave this in here. Resume. It'll touch off. And then once it's done probing for the length, it'll prompt you to turn on the spindle. I'm not going to turn it on just because that would make a lot of noise and I'm not actually cutting anything. Resume. It'll go through its cut. And then when it's done with that, it'll prompt you to load the next tool. Let's just speed this up. It's done with tool number 1. It'll make sure you turn off the spindle. Move to the front once it's safe to do so. Change the tool, whatever, use your wrenches, blah, blah, blah. Magic happens. New tool's loaded. It touches off, finds the new length, and then once it's done with that, it'll ask you to turn the spindle back on, and it will cut the remainder of the toolpath. So, that's basically all there is to using the bit setter. If you didn't have a bit setter, you'd probably have to split this up into 2 programs. So you would load a tool, run the first program, change out your tool, find your new 0, and then run the second program. Here, really it's just clicking resume, changing a tool. All the tool measurement is done for you. So that's bit setter in a nutshell. Let me see if there are any other questions. How fast can go Shapeoko? So the Shapeoko, we limit it to 10,000 millimeters per minute, which works out to about, I want to say, 500 inches per minute. It can go pretty quick, but we never recommend pushing all the way to the limits, because if the slightest thing goes wrong, like if you smack into a workpiece, you're going to start losing steps. If you have really dirty view wheels, that's also going to negatively affect, like you might lose a step there. The faster stepper motors go, the lower torque they have. So there's sort of a safe limit that we try and find, and we set that at 10,000 millimeters per minute. Okay, so let's see. Any other questions? Okay, so what does the base height do in model, no matter what I set it to? 3D view always shows going all the way down to full stock depth. I think that you're asking about a Carbide Create thing. Let's see, let me go back to my desktop. Pull up Carbide Create. Let me make sure I'm showing that. Yes, I am. Cool. So, in your setup, I think this is what you're talking about. If not, correct me. Your stock thickness is how thick of a piece of material you're trying to cut through. For the depth of your toolpath, that is set over here under cutting depth. And usually I'm cutting all the way through something, but this doesn't change dynamically between toolpaths. So whatever you last input or whatever is the last safe depth less than or equal to the stock depth or stock thickness will be what gets put in here. So just double check that your intended depth is set for each toolpath every time you make a new one. Can you give the belt a twang to show us tension and share any recommendations for adjusting the belt brackets to avoid colliding, rubbing with the y-axis view wheels? Sure. Let's see. Let's zoom in on a rail. Okay, so I'm going to go through the exercise of loosening and focusing, reattaching a belt. So I think it's a 4mm Allen key. So the way I go through this normally is I will fully tighten the back belt anchor so that you're not double tensioning these, but you want to loop the belt through and make sure that it's under the front one and down for the back one, and then that the belts sort of interlock when you mesh down on them so that the teeth are help preventing them from slipping, and then hold down the belt clip and just pull it. And if you can reach all the way to your front base plate, you need to tighten this up a little bit So just increment it tooth by tooth until you just get to the point where your fastener will reach the belt clip. I think I could probably go one more tooth here, so let me do that. And then, so now my M5 bolt, I think it's M5, just barely catches the, it's a little too far actually, so I'll go back one. So just until your fastener, don't use an extra long bolt, because if you start catching the belt clip like way out here, you're going to over-tension the belt and you're going to damage the stepper motor axle. So once this belt clip just catches the fastener, maintain downward pressure here, otherwise the belt's just going to slip out. And then just basically tension that all the way until the top of the belt clip touches the base frame, because that is what keeps the belt clip from flipping forward. So because it's an angled bracket, if the belt clip does this, all the belt will be let out. As you're tightening it, you can sort of tweak the belt clip over so it is rotated further away from the V-rail, and that should buy you enough clearance to get your V-wheel all the way up to the front. I've heard of some people, they just take a little sandpaper and they chamfer that top edge of that clip. You can do that, but I personally don't have any interference issues here. And then let me see if you can pick this up. Can you hear that? That's the relative tightness, and keep in mind that that twang will change depending on the free length of belt. So like if my gantry, if my carriage was all the way up here, there'd be a much shorter length, you'd get a very different frequency. So sort of if you have like an XL, standardize where your gantry is and where your carriages are so that you're plucking the same length of belt. Let's see, is there a way to store and recall X and Y 0 points, perhaps using G-code? Not in G-code, it's really just your origin. So you just ref your X0, Y0. Carbide Motion doesn't support work offsets, so like G54, 55, whatever. But referencing your origin would be probably the easiest way to go, and just use that as your fixed reference point. Okay. How reproducible the coordinate system is after restarting or power cycling the machine? Pretty darn accurate. Within like a thou or two. The biggest thing that'll affect whether or not you can home and then pull back to the exact same coordinate is for the stock machine, you really don't need to worry about things, but if you have an XL, let me just jog the machine forward so I can illustrate this. So on an XL or a double XL, when you turn on the machine, you'll hear it click or it sort of kick. And that's the stepper motors locking into a rotation. So on those larger spans, where you can get a little bit of racking unevenly on the carriages, when you first turn on the machine, one stepper motor might lock in this way, the other stepper motor might lock in this way. So if you have the same exact initial conditions, like if I move my carriage all the way to the front stops here, and I turn on the machine, it's always the motors will always lock in the same way. And that will be one way where you can ensure that within the resolution of the motors, you are homing to the exact same location. Preventative maintenance on the Shapeoko, cleaning for the most part. As long as you keep everything clean, your router should last many dozens of hours. Other than that, hygiene is the big one. Okay. I think that is everything for now. And let's see, before we wrap things up, I do want to mention that we have, hold on, my coworker is laughing at me from off camera. I wish you could see this. we have a new policy called the, let me pull this up. What's it called?
The we've got you covered policy or something like that.
Carbide Create.com/warranty. The unofficially we call it the We've Got You Covered. So let me make sure. Let me pull up my screen again. Cool. So now within our warranty, we have a 30-day policy where if you screw something up, like in good faith, you're not maliciously crashing the machine, we'll cover it. So if you accidentally ram your CNC into the side end plate and you break a V-wheel, we'll cover that. If you accidentally crash into your stock and you break your end mill, if it's one of our end mills, we will provide you a new end mill. So that's just one thing we're trying to do to help anyone who's just getting started with CNC feel really comfortable just running these things. For the most part, these machines should be fairly safe to operate. You're not going to blow up the machine. The most likely thing you'll do is you will crack a V-wheel or you will break a belt. And in those instances, we will replace those objects for you. Certain consumable objects like the MDF, or if you're machining a really expensive piece of, I don't know, mahogany or something, that's not on us. But anything that we sell, we will try and make right for you. So that is the It's On Us
Sure, why not?
30-day user error warranty. And with that, any last minute questions, please drop them in the chat. Otherwise, this has gone on for far too long. I expected this to be a half-hour session.
How dare you?
But let's see. Is there a VFD setup you could recommend? We don't officially have one to recommend just yet, just because there's so many out there. As we get more experience, maybe we can, but for the most part, at this moment, you should probably ask other people who are using them just because there's so many. If I can ever get my Carbide Create to load, will my 1-year free use start then? I believe it is from the date that you got the code, but I would say, yeah. If you have any issues with that, let us know. We might be able to add an extra month for you or something. But I think it is from the date that that you requested the license. Does the 30-day user error apply if I just bought my Excel and such less than a month ago? Unfortunately, HR is here and they're telling me no. Let's see. All right. Well, I think that is everything on my agenda for today. We will be we'll be doing a Q&A, hopefully, at the beginning of every month, just so that this is a recurring thing and so that anyone who's just bought a machine can ask new questions. And we'll find other fun projects to do for the remaining weeks. So hopefully the Q&A will be a regular recurring thing. And if you have any more questions, drop them in the forums on our social media so we can help you answer them. But other than that, thank you all for joining. And I'll be hanging around in the chat for a couple more minutes for any absolute last-minute questions. But thank you all for tuning in, and we'll see you again next week.